So we're going to look at division with decimals. And again, this is something that where you have learned rules for this, but we're going to talk about why the rules work the way they do. Okay? I want you to have, part of this class is helping you to have not just, I know the rules for doing things, but I want you to have an understanding of why those rules work the way they do. So, here we have Victor is trying to do division problems with decimals, but he doesn't remember the standard algorithm. An algorithm is just a set of steps, by the way. He couldn't remember what he was supposed to do. So he rewrote the problem as a fraction and know that he should multiply by a giant 1, but then he got stuck. Help him out by finding a giant 1 that will change the problem into one that has no decimals in it at all. And then it gives you a hint. And I didn't close the parentheses. Okay, so what can we multiply this by? What kind of a giant 1? Yes, sir. Pardon? Yeah, you could. There's an easier way to multiply it by a number that you don't even have to do very much thinking about to multiply. 5 over 5 will absolutely work in this particular case, but there's an easier way. Anyone think of a different giant 1? I know some of you have things written down. Yes, sir. We just said 5 over 5 works, but there's a simpler one. What did you write, Alex? 100? Okay, 100 over 100 will absolutely work also. There's an easier one than that. Well, let's look at the hint. Think of the place value of a number that is 1 past the decimal. What is the place value of that for? 10. Multiply by 10 over 10. And then you get 34 over 2, which is 17. A 100 over 100 works, but now you've got bigger numbers. 5 over 5 works, but then not very many people immediately look at 3.4 times 5 and go, oh yeah, that's 17. Okay? Some people can, and that's fine. All right, let's use the same procedure here. So 0.84 divided by 0.21 is the same thing as 0.84 over 0.21. In this case, what do you think we should multiply the numerator and the denominator by? What do you think? Jill? Yeah, 100 over 100. Because that'll get rid of the decimal for us. This will be 84 over 21. And for that one, well, I can see that 21 goes into 84 4 times. So that's just 4. All right, so after looking at your work, Chad noticed that the answer to the first problem was the same as the answer to 34 divided by 2. The answer to the second problem was the same as 84 divided by 21. And he said, that's brilliant. Well, he thought that. That means that 0.09 divided by 0.2 is the same as 9 divided by 2. What do you think? Will Chad's idea work? No. Can we do the same procedure we did before? So 0.09 divided by 0.2. What would we have to multiply by to get rid of the decimals entirely? Yes. Well, if we multiply by 10, 10 times 0.09 is going to be 0.9. We need to multiply by 100. So basically what we need to look at is the biggest place value we've got. We've got the tenths place. So we'll multiply this by 100 over 100. And that's going to give me 9 over 20. Now we can do a long division with that. So 20 doesn't go into 9, but 20 will go into 90 4 times. We'll add another 0 behind the decimal. 20 into 100 goes 5 times. So this is 0.45. So this is one way that you can divide two decimal numbers. Multiply by the highest place value over itself. If it's hundredths, 100 over 100. If one of them has something in the thousandths place, you got to multiply by 1,000 over 1,000. And then just do the division. Now, let's turn that over onto the back, please. And let's look at the standard algorithm for division by a decimal. When you're dividing by a decimal number, one way to do this is to count how many digits the decimal point must be moved to the right in the divisor so that it becomes an integer, that is a whole number. So if you've got 8.3 divided by 4.07, the 4.07 is out here, and some of you may have memorized, oh, this decimal needs to be right up against the division sign, so it's got to move 2 places. So this decimal must also move 2 places. Well, when you move those 2 places, what are we actually multiplying by? Someone said it. They're multiplying by 100, for both numbers. We're multiplying the 8.3 by 100 and the 4.07 by 100. That's why this works, because you're multiplying both numbers by 100. You're multiplying by 1. So the giant 1 property illustrates that here. We ended up with 830 divided by 407. It's the same thing. All right, so I want you to do these 3 problems. You can either do it by the standard method, or you can multiply by a giant 1, but I want to see you do each one of those at least once. Okay? So you can't do them all by the same method. And I'll give you a couple of minutes to do that. God bless you. Once you have your answers, check with the people sitting near you. All right, you have one more minute to discuss it, and then I'm going to pick on people. You have one more minute to discuss your answers, and then I'm going to pick people.
You changed it from 1.5 to 1.970.
Okay, that's a minute. So my random number generator has picked people. I don't want you to just tell me the answer. I want you to tell me what you did So let's see, for the first one, Des 10. Nyla, tell me what you did.
I got 10, because.
Wait a minute, you got 10. What do you mean? What did you do with,
Okay, I did times 100.
you did times 100 over 100?
Yeah.
Okay. And so what does that give you?
250
Uh-huh.
divided by 25.
Exactly right. When you multiply by 100, you're going to move the decimal 2 places. So this ends up being 10. Very nice. Well, that's loud.
So is there some kind of bird gladiatorial combat going on?
Could be.
Could be.
Now, yes, ma'am.
When you get it the other way, would it be 0.01?
Nope. All right, so if you do it the other way, you have 0.25 divided into 2.5. You move the decimal 2 places to the right, so you have to move this decimal 2 places to the right. So your decimal is here. Then 25 goes into 25 once. And 25 goes into 0 0 times. I think on this one it's actually easier if you multiply by 100 over 100. It's real easy to see. 250 divided by 25 is 10. All right, let's see. For the second one, desk 6. Gordon, tell me how you did this one, please.
I multiplied 100 over 100.
Okay, and when you did that, what did you get?
Negative 1,120 over 7.
Great. And then you did the long division? So let's see, 7 goes into that once, with a remainder of 4, bring down the 2. 7 goes into 42 6 times. Subtracting that, we get 0, and 7 goes into 0 0 times. So you should get a final answer of what, Warren?
Negative 160.
Yes, negative 160. Yeah, I don't think that was Warren. All right, and then the last one, desk 4, Alex. Did you do it by multiplying, or did you do it by the standard method?
I tried doing the standard method, but I think I got it wrong. I got confused.
Okay, well let's see if we can fix that. So we have 0.3 divided into 591. So what did you do?
I divided 0.3 divided by 491.
Right, but what about moving the decimal?
Yeah, I didn't move the decimal.
Okay, you have to move the decimal. So the 591 doesn't have one originally, so we have to add it, and we need to move the decimal 1 place on both of these. So now we can just do the division. 3 goes into 5 once, leaving us 2. We'll bring down the 9. 3 goes into 29 9 times, which is 27. Bring down the 1. 3 goes into 21 7 times. Bring down the 0. And 3 goes into that 0 times. So it's 1,970. Yes, ma'am. Shh. Yeah. So if we take this and multiply top and bottom by 10, we'll get 5,910 divided by 3, which is what we end up with over here after moving the decimal. It's just that multiplying by 10 moves the decimal for you. And then we just divide the same as we did over there. Oops, sorry, I wrote the wrong number here. Okay. Any questions about dividing with decimals? Yes, ma'am. Pick whichever one you like. I'm only rarely will I say you must use this method. Occasionally I have to because I need to test to see if you know more than one method, but on this, whichever one appeals to you. I just wanted to go through this so that you know, okay, well, why does that method work where we move the decimal? Okay? All right, that is it for today's lesson.